Well, there's no business data analytics without data. So, dead or alive, we're going to need to see some data. The first step in any business data analytics problem is to find the right data and prepare it. Sometimes data exists and we have to prepare it. In other scenarios, part of our job is to go out and collect or gather the data necessary to complete the task. Data takes many forms. Intuitively, we might think of numbers or even spreadsheets of numbers, but data doesn't even have to be numerical. Data may be generated from a range of different sources, everything from surveys administered by individuals face-to-face to retail transactions. Data also comes in different quantities. Some projects call for humongous data sets. In other scenarios, a small data set is sufficient to make inferences. For a rare disease, a treatment successfully tested on a dozen patients might be enough to draw conclusions, for example. It is when we organize, process, and analyze data that we generate information. We use data, information, experience, and intuition to derive knowledge. And this is where, as an analyst, you are truly indispensable. There are a few basic ideas I want to introduce about data. First is the difference between a population and a sample. A sample is a subset of a population. Often, we must use a sample because it would be too difficult or expensive to reach every single member of a population. For example, it would be difficult to conduct a face-to-face interview with every single WVU student. But if we spent an hour outside the mountain layer, we could probably get a decent cross-section of students. Data may also be classified as cross-sectional or time series. Cross-sectional data refer to data from many subjects collected at the same point in time, while time series data is collected over several time periods, focusing in on specific groups of people, events, or objects. Longitudinal studies, for example, follow a sample over a long period of time. Data may also be structured or unstructured. Until quite recently, our focus has been on structured data because we lacked the tools to evaluate unstructured data. But technology has come to help us out. But if you took or are going to take MIST 351, you're going to work with structured data in SQL that conforms neatly to a row and column format. Unstructured data is a little more unruly and refers to things like paragraphs of text, images, and video and audio recordings. These types of data may also be generated by humans or through automatic processes. Supply chain management, for example, relies heavily on data generated through automatic processes, like retail transactions, to determine exactly what needs to be shipped where and how quickly. Big data is a term that is more and more common and that you've probably heard at least a few times over the past few years. The exact definition of big data is a moving target, which is one of the reasons why I honestly really hate the term. But it is characteristically defined by volume, velocity, and variety. So there's a lot of it, we're collecting it quickly, and it's coming at us in all kinds of formats. Big data is kind of a sexy term and a really popular buzzword right now. But there's actually no guarantee that any big data set is going to yield some useful insights. And again, this is where it's important to have a skilled and thoughtful analyst to shepherd an organization through their data sets. Without you, data doesn't mean very much. So this figure illustrates a simple taxonomy of data. And I recommend keeping this handy as you delve deeper into the world of data analytics, or at the very least it might help you out on a homework assignment or an exam. So first, data is organized into structured and unstructured formats. Unstructured data can be a little challenging to work with, so we're going to start our journey by digging into structured data, which is first divided into categorical and numerical classifications. Categorical data would refer to things like surveying everyone in the class on their favorite pizza place. And while you might like Pizza Al's more than Fat Angelo's, there's no measurable difference between the qualities of these pizza places. And frankly, there's nothing better than the Italian hoagie pizza at Fat Angelo's anyway. But that's my personal opinion, and there's no quantitative way to measure my preference for that pizza over your undying passion for Pizza Al's pepperoni pizza. Numerical data, on the other hand, are measurable. For example, this section of Buddha 450 has more students in it than the section last fall. Or, my husband's Miata gets better fuel economy than my Corvette. Although, to be honest, I think my Corvette's probably more fun to drive. It's at least faster. These are measurable. We can measure the fuel economy of two vehicles and determine which one sips a little bit less gas than the other. I challenge each of you to read through the material and come up with your own examples of nominal, ordinal, interval, and ratio data. Or you can stick around for the next slide. So pretend you're in marketing at Snowshoe Resort and you want to find out a bit more about your younger clients. So you survey 20 of them. You ask about their music streaming preferences, the food quality, closing time, and the amount of their own money they spent. And each of these represents a different type of data. Music streaming preferences are an example of nominal data, the food quality an example of ordinal data, the closing time an example of interval data, and the money spent is an example of ratio data. Finally, data comes in many formats. For this class, most data will be provided in comma-separated values or CSV format, or some Excel format, and you'll either work in Excel or import these file formats into R and RStudio. If you haven't already, make sure to install R and RStudio. Don't worry, I don't expect you to have any experience with R and RStudio, although if you have a little bit, it isn't going to hurt. But by the time we wrap up this class, you're going to be feeling pretty good about your R and RStudio skills. So stick around and make sure to get R and RStudio installed.